Hey guys, last section. Today we're looking at the stretches and compressions of your sine function. So we're looking at section 6.6. Super quick refreshers. You've got to know your 5 main points of your sine function. It should produce this kind of graph, and we get this graph if you consider the height of something that would be on anything circular as it moves around. The other thing you need to remember is from our quadratics unit when we started stretching and compressing functions, and it's also a refresher from yesterday as well. Any value that is added to the end will shift your graph up or down. Anything that is on the inside will move it left or right. Again, the only part that you have to be aware of is this has a minus sign in the equation. So if you put a negative number in here, your equation would have x plus a value. So the sign on the inside here is going to be a little bit backwards. If this has x minus a number, it is actually moving to the right. If it says x plus a number, it's because there's a negative value in there, and it will move to the left. Okay, so just be aware that the signs might be a little bit backwards. And the last thing that you need to remember, which is what we're going to focus on today, is if there is an a value, a number in front, your graph will be vertically stretched if the a value is larger than 1. If the value is between 0 and 1, your graph is going to be vertically compressed. Don't worry about the negatives because it's a periodic function. You don't have to worry about the reflections. They just move left and right. Okay, so let's get into some examples. We're taking that idea and we're going to apply it to our sine functions. So if you have a sine function and there is an a value in front of the sine, it will be stretched or expanded if it's larger than 1, and if it's a decimal between 0 and 1, it will be compressed. The other cool thing is that once you see an example, you'll get it right away, that this a value right in front, it's actually the amplitude of our new graph that we create. Okay, so as we go through, you will notice that connection. All right, so let's look at an example. We're just going to hop straight in. There we go, down here, there's our example. So we can always start with our 5 main points. And again, if the grids here are a little bit small, I'm sorry, I'll try and say them out loud for you. So 0, 0, 90, and 1. Now actually, I'm going to change my axes here. We're going to make this 1, 2, -1, -2, just so we can clearly see what is happening. So our first point is at 0, 0. Our next point is at 91, 180, 0, 270, -1, and 360, 0. And we get those from the table of values that you had to memorize, which is right on our first slide. It's the 5 main points. Okay, so I've got my 5 main points. I am going to do just a little bit more graphing. I'm going to throw in some extra points because I want you to be able to see it, but when I do it with my pen tool, it's really ugly. So there's our basic sine curve, but we're focusing on the 5 main ones. Now, each one of these is going to be stretched or compressed vertically, okay, up and down. So our a value is 0.75. That means that the distance from our equation of the axis up to our point is going to be multiplied by 0.75. So my new amplitude, instead of having an amplitude of 1, is going to have an amplitude of 0.75, which is going to be there. So I've taken a distance, a vertical distance of 1, I've multiplied it by 0.75. I'm going to take the vertical distance of -1 and multiply it by 0.75. You should get -0.75. Now, these next 3 points are really nice. 0 times 0.75 is 0. This point's not going to move. This one is the same thing. And this one's the same thing. So 3 of our points don't move. And we have a graph that now looks like it's been vertically compressed. So I'm going to do my best to connect my dots and give you a really pretty curve. And then you can compare it to the little black dots that I've put on. There it is. Okay, so the black dots are my basic sine function. The red line is my compressed sine function, and you've got it. So all I've done is I've taken my height and I've multiplied every vertical value by 0.75, and we're only multiplying 1 and -1. The second part of the question says state the amplitude. This is the amplitude. So the A is 0.75. And if you come here and you look at your graph, remember we're going from the equation of the axis to the maximum. it was at 0.75, right? Right there, 0.75. Okay, and that's essentially all we're doing, okay? I wanna look at an example where now we mix all of our compressions and our shifts left and right and up and down, and we're gonna put them all together. So this is what you're gonna be working on for the rest of the section. They're pretty straightforward, and then you're reading the graphs at the side, or the values at the side. So we have this crazy function here. Go step by step. This one tells us it's going to go up 2 because it is a positive 2. This one here is a negative 120 or a minus 120, but inside the brackets it's backwards. So this is a plus 120, which means it's going to go 120 degrees to the right. Okay, right. So I know it says minus, but this is to the right. And then the last thing is we have a vertical stretch by a factor of 3. Stretch by 3. Okay, so once we graph it, we can state all of these things here at the side and you'll be good to go. I always start with my basic function, which, to be honest, I don't think will fit here for a second. We are going to be a little bit shy. I might have to change those. Okay, I'm going to change one of my equations. Can you please change this to 1? And this way it'll fit on our graph. Otherwise, we'd have to do quite a bit more work. So we're just going to switch this to 1. So please make that correction. Instead of +2, make it +1. And this way we can see all of our points after we graph them. Okay. Again, I always start with my basic function. So sine 0, 0, 91, 180, 0, 270, -1, and 360, 0. Just if you can't see the numbers, this right here is 2, this up here is 4, this one here is -2, and this one here is -4, okay? And you can see my 5 main points. So now I'm going to take my other marker, I'm going to stretch it by 3 first, and then I'm going to shift it right and up. So this will vertically stretch it. It's going to change the amplitude. If my amplitude was 1, 1 times 3 is 3. So instead of going up 1, I'm going to go up 1, 2, 3. Okay? And every 2 squares is 1 unit, which is why I'm counting 6 squares up. These 3 points here are not moving at all. Anything times 0 is still 0, so they don't get moved. This one down here is -1. -1 times 3 is at -3, so I'm going to put a dot at -3. Okay, so I have a dot here, 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 and down at the bottom and up top. So now you can see this thing has been stretched quite a bit. It's a sine curve that's been pulled up, but the distance or the period has stayed the same. Okay, so now I've got these red points. I'm going to take another color marker, let's go blue, and I am going to shift each one of them right 120 units and up 1 unit. So let's start with this one. I'm going to go up 1, and I'm going to go right 120. Okay, this right here, I'm trying to make it bigger. This is my new starting point. So I'm going to go over 120 and up 1 for every red dot that I have. And if some of our dots don't, if one of our dots doesn't fit, that's fine, okay? So this one was at 90. I have to go right 120. 120 plus 90 is 210, so I'm over here, and I'm going to go up 1 unit, which puts me up at the number 4, right? Because it was at 3, I'm going to go up to 4. Okay, go to my third dot. I'm going to go right 120 units, and then I'm going to go up 1 unit to there. I'm going to go to my fourth dot. I'm going to go right 120, 30, 60, 90, 120, and I'm going to go up 1 unit right there. Okay. Now this last dot, you know what? My graph isn't big enough. It didn't fit, so I'm not going to put it. You should realize that it would continue. And now I've got these 3 main dots. Again, don't draw me zigzags. You can connect them. Draw your best curve that you can. And well, you should get a really pretty sine curve. It would continue somewhere over here. Okay, and that's all you have to do. go back, make sure we've got all of our values at the sides filled in, and you have finished the section. So the phase shift is the left and right. This one has gone right, 120 units. The amplitude was 3 because we're looking at this number. So the amplitude is 3. The vertical displacement is how much our equation of the axis has been shifted up. It's gone up 1 unit. So this is up 1. And then the equation of the axis, if I were to draw it in, I don't actually really need it here. There it is right there. Okay. Let's put this in. So the equation of the axis is y equals 1. Okay, it's the same number as your vertical displacement. I have 2 more examples. I'm not going to do them. If you would like to do them to practice on your own, you are welcome to. And then a quick summary, which is from the back of your book, or the back of the section of your book listed on the last slide. So guys, you've done it. You've finished all of your trigonometry, and so you can just start working on your task. Good luck. We'll see you next unit.